Hi, welcome to Electrician Ed. We will be talking about dedicated circuits and nameplates in this video. So creating dedicated circuits is one way to protect electrical equipment and the entire electrical system from overloads. In this video, we're going to be talking about individual branch circuits and how to determine whether your electrical equipment should have its own dedicated circuit. At the end of this video, we'll be doing some practice. I will show you how to find pertinent information and do calculations required for determining whether a particular appliance should have its own dedicated circuit just by getting information from that appliance's nameplate. So what do we mean when we use the term dedicated? The NEC never actually uses that term. Instead, the closest thing to it in the code is individual branch circuit or individual circuit sometimes. You'll see that often in manufacturer's instructions for installations, or even just individual. Usually dedicated and individual mean the same thing, but it doesn't hurt to double check terminology with anyone that uses it to make sure you're both on the same page. In this video, again, I'll be using the terms individual branch circuit and dedicated circuit the same, interchangeably. It's worth noting that oftentimes electricians will kind of use terminology loosely. And I think by the end of this video, you'll probably know the difference, and you'll realize that if someone says that they're bringing a dedicated circuit to a bedroom, they don't mean they're bringing an individual branch circuit to it with all of the outlets that are in that bedroom. And so depending on who you're talking to, there may be a difference in that terminology. Again, in this video, I will be using dedicated and individual as if they mean exactly the same thing. But really, it's only individual branch circuit that's technically defined in the code. Okay, most important, dedicated circuits supply one and only one utilization equipment. A utilization equipment is an appliance or something that uses electricity to do a particular job. If you add anything else to a dedicated circuit, it loses its privileges and it's no longer an individual branch circuit. Electric dryers are a type of utilization equipment that are normally not fastened in place. And that's kind of an important detail that'll come up later in the video, whether something's fastened in place or not fastened in place. It makes a difference. Here's another utilization equipment, a luminaire, a light. I would say that luminaire was fastened in place. Blenders are a type of utilization equipment, and in this case, it's not fastened in place. This is actually a good example because it's a kitchen appliance, and that'll play into the rules later as well. Here's another example. Anything that uses utilization equipment, or excuse me, anything that uses electricity is a utilization equipment. Okay, for receptacles on a dedicated circuit, you can only have one receptacle. Duplex receptacles like this one have 1 plus 1. That equals 2. That's one too many. So they don't work as an individual branch circuit. Someone could come along and plug in another piece of equipment there, and then that circuit would be supplying more than one thing. So technically, you can only have a single receptacle like this one on an individual branch circuit. That's designed for only one attachment plug. This is perfect for an individual branch circuit or a dedicated circuit. Okay, hardwiring is another way to go about an individual branch circuit. You can have a receptacle or you can hardwire a piece of appliance directly to the branch circuit. That's where you do away with the receptacle completely and you connect the appliance directly to the branch circuit conductors or the utilization equipment, whatever it is. In this case, I found an example of a transformer. It's hardwired right into the branch circuit. Okay. Um, this is an oven ventilation hood, and we're looking up at it at this view. Depending on the way the hood is designed, sometimes you'll have a receptacle behind it, and other times you may have to hardwire the connections like this one is. Either way, you don't plan on disconnecting the appliance very often. It is a fastened in place appliance, and you control it from a switch normally. There are only a handful of items actually in the NEC that call for individual branch circuits. Any branch circuit that's not rated either 15, 20, 30, 40, or 50 amps. So if you have equipment that needs protection rated differently from these standard overcurrent protection device ratings, whether it's smaller or larger, it must be fed from an individual branch circuit. And I can think of probably an example might be something that calls for maximum 25 amps. Well, that you can get a special breaker for that, but that is not in the code book as a standard. So it would have to supply only one piece of equipment. If you see a breaker that has like 45 amps or 35 or something like that, that should technically only supply one piece of equipment. Also, if you have a cord and plug microwave oven hood combo unit, or I think even just an oven hood, it needs an individual branch circuit. And then now, not everybody is going to have a boat dock, but if you have a receptacle that's designed for a boat, shore power to a boat. So you come up, you dock your boat, you plug into your shore power. And these are more common in some locales. But receptacles for boat shore power have to be provided from a marina power outlet or panel board with nothing less than a locking 30 amp single receptacle by an individual branch circuit. So it could be, I guess it could be more than 30 amps, but it can't be anything less than that, and it has to be an individual branch circuit supplying that shore power. It also, by the way, will have to be GFCI protected. Or if you have an electric vehicle charging receptacle. So any receptacle that's intended for charging electric vehicles has to have its own circuit. Okay, and if you have a hydro massage bathtub, that's another one. Manufacturer's instructions often ask for a GFCI protected, dedicated, or they may say individual circuit to power the pumps and other components of hydro massage tub. And that's in line with the NEC requirements as well. And note that if the instructions depict a GFCI duplex receptacle device, that could cause some confusion. And sometimes they do depict it that way. But what you're learning now is that that would not technically be an individual branch circuit. It may be okay because it's out of the way. You'd have to check with your authority having jurisdiction, your AHJ. home inspector, basically, whether that's appropriate or not. There's other ways to supply ground fault circuit protection for your hydro massage bathtub. In some of the examples I saw, they actually required more than one circuit up there to for all the equipment that was in being used in a hydro massage bathtub. Okay, next, if you have a 15 amp branch circuit in the kitchen area, so sometimes a refrigerator will put that on a 15 amp branch circuit on its own dedicated circuit. It wouldn't have to necessarily be a refrigerator, but usually that's where we use that exception. Because it's an exception because normally anything in the kitchen has to be a 20 amp small appliance branch circuit if it's in the kitchen, dining room, or other similar rooms like that. Pantry, I think, is another one. Breakfast nook has to be from a 20 amp, what we call a small appliance branch circuit. This is the one exception. If it's supplying a single piece of equipment, it could use a 15 amp breaker and 15 amp wiring to that receptacle. But remember, it has to be an individual branch, an individual circuit, a single receptacle. We can use the rules laid out in the NEC to discover many other appliances that deserve to have their own dedicated circuit for them, beyond the ones that we just listed. So I call this extrapolating the dedicated circuits using the rules. And the first one that comes up is fixed electric space heating. And by fixed, I mean not the type that you carry into the room and plug in to a wall receptacle. These are the kind that are attached to the house in some way or another. And fixed can be as simple as having 2 screws or one single nail holding something on. It's fixed in place. Anyway, you can put 2 or more fixed space heatings on a shared circuit. That's okay by the NEC, providing these special rules are taken into consideration. The branch circuit cannot be more than 30 amps for any fixed space heating equipment. Okay, but also if you have 2 or more, the combined total cannot be more than 80% of the rated load. So if you have a breaker, it's got to be sized 125% bigger than the rated load of the combined amperage. And it can't be more than 30 amps. So what that means is if you have 2 floorboard heaters and together they are rated 24.1 amps or more. Well, extrapolating from the rules, we would have to have dedicated branch circuits for both of them, for each of them. The next thing that comes up is electric water heaters, the storage type. If they're 120 gallons or less. These are often placed on their own circuits simply because the code requires their branch circuit over current protection devices, or the breakers, and their conductors to be oversized by at least 125% of the water heater's ampere rating. So this is basically the same thing as the 80% rule. Water heaters often get their own dedicated circuit because of this. Central vacuum outlet assemblies. Here's another one. The NEC allows you to put central vacuum outlets on a general purpose branch circuit along with other receptacles or lights in the same area. However, Every general purpose circuit that's used this way has to be rated double the rating of the central vacuum uh, requirements. So the ampacity that the central vacuum is going to require, the branch circuits would have to be rated double that amount. And the total of all the connected loads that are going to be on the general purpose branch circuit can't be more than 100% of the circuit's ratings. Another thing that causes people just to throw up their hands and say, okay, manufacturers tend to recommend putting their systems on dedicated circuits. But that's not the same thing as demanding them. So you could figure out that, yes, you could put it on a general purpose branch circuit and you're probably going to be okay. Vacuums are only going to be used once in a while, and chances are you won't be using other things on those branch circuits. So the NEC does allow for that kind of common sense stuff. Room air conditioners, the type that are fixed in place, they can also be placed on a circuit with other loads, but the entire circuit has to be rated double the ampacity of the AC, assuming that it's fixed in place. And I didn't mention it before, but this is known as the 50% rule. Fixed in ACs tend to require more than 10 amps. Some in-wall units, they're going to need even more than that, like at least 20 amps or more. So often they end up getting a 30 amp receptacle. Manufacturers also tend to call for dedicated circuits. If an individual branch circuit is used, the 80% rule comes in. The rating has to be of the circuit has to be 125% at least of the rating of the air conditioner's nameplate. So a 30 amp circuit could handle a 24 amp room air conditioner, or 24 amps, yeah, a 24 amp room air conditioner one, if it's an individual branch circuit. Okay, water pumps are another one. If they're intended for fire protection. So this rule is really, it's an exception for a special case. It's almost too technical to even be helpful in this discussion. But if your dwelling unit, in other words, your house or your condo, whatever, if it uses the NEC's special permission to have 2 to 6 disconnect switches. So most places only have one single throw, and you can shut off all the electricity. But there is that special rule in the NEC that allows you to have up to 6 handle pulls to turn everything off. But they have to be grouped in the same area. And that's mainly for the convenience of the fire department, because they'll have to shut everything off when they're responding to a fire. However, here's the exception. If there's a water pump on its own feeder line from the metering equipment with its own dedicated overcurrent protection device, it can be used as one of the 2 to 6 disconnects, even though it's not grouped with the others. But it has to be an individual branch circuit. So also, I might as well note this. There has to be a placard if you have a situation like that. You need a sign right there by those other 5 disconnect switches, or could just be a main breaker with this other placard that says there's also another switch, and it's got to explain where it's located so that a fire department will know about it. Okay, and then there's also, I've already flipped to this part on the slide, but there's also many, many others that by using these rules, the 80% rule or the 50% rule, because of their load ratings, they will need dedicated circuits. But I've just shown you how to figure that out, even if they're not named in the code. If you have the breaker space, um, keep in mind that you're always welcome to put it on a dedicated circuit. There are some general rules for dedicated circuits. The NEC requires us to follow the manufacturer's installation instructions. Maybe I should have said all of this first because I've already mentioned it several times. But this is because the NEC also requires all appliances rated over 50 volts to be listed by a listing agency such as Underwriters Laboratories, UL. And the listing requires products to be tested against the uses that they'll be intended for as they're laid out in the manufacturer's instructions. So the UL strongly requires appliances to be installed according to manufacturer's instructions. So follow manufacturer's instructions. The second thing is that the branch circuits cannot supply loads that are rated higher than the branch circuit itself. So branch circuits are not allowed to supply loads collectively or individually that are rated higher than the circuit is. If you plug in too much at once, hopefully you'll trip a breaker and avoid a fire. So this rule just makes sense. It's really a rule for the homeowner to know also, because an electrician can't know who will plug in what into a receptacle. Okay, the next two rules are both for 15 and 20 amp circuits. First, each piece of general cord and plug connected appliances that are not fastened in place on general branch circuits must be rated no more than 80% of the entire branch circuit. This is the 80% rule. And second, on 15 and 20 amp multiple outlet circuits, the total can't be more than 50% of the entire circuit rating. So on a 15 amp circuit, that's 7.5 amps, and you only get 10 amps on a 20 amp breaker. So let's take a few nameplates out and do a little practicing. We'll apply these rules that we've talked about. This is a nameplate for a medium-sized microwave, and this is not a commercial unit. It's just a microwave designed for a household. You can see it's UL listed, and if you look over here at the input voltage, it's rated to run at 120 volts AC. That's household voltage, and at 60 hertz or 60 cycles per second, which is what the United States and Canada use, and maybe a few other countries around the world. The output power is 1200 watts. This is not what you pay for, I might point out. Since it's on the output side, it's the power that the microwave is putting out. It's the energy you're putting into heating your food. Some of the power is lost And I can prove that. So normally you would look at wattage and see the voltage. You'd normally divide the wattage by the voltage to get the current. So 1200 divided by 120, you get 10 amps. But if you look here, the rating is 13.8 amps. It's almost 4 amps difference. So that's the true power that it takes to create the energy that you'll be using to cook your food. So it's not really very efficient as an appliance. But the important thing, though, is that the question, do we need a dedicated circuit for this microwave? You could make that argument. However, if it's on a small appliance branch circuit with all the other things that are that could possibly be plugged into that branch circuit, this unit does not exceed the cord connected, not fastened in place equipment 80% of the circuit rule. So that would be 16 amps, and this is only 13.8, so it wouldn't be required to have a dedicated circuit. However, if you did have it on a dedicated circuit, it would be permissible to use this one for the 15 amp individual branch circuit exception. Normally in the kitchen, dining room, pantry, breakfast nook, etc., remember you can only have 20 amp appliance circuits there. So any receptacles that are normally there could only be 20 amp circuits. This is the exception. And you'll find that in NEC article 210.22 and .23. This is a nameplate for a Pampered Chef air fryer. We like this unit. It makes food crispy and delicious. The input voltage is 120 volts, again at 60 hertz. And notice on this nameplate, they don't show the amp rating. In this case, you have to do the math. 1700 watts divided by 120 volts equals 14 amps. So this is where you really might be getting close to needing a dedicated circuit just for this one appliance. Now, if it was just 50 watts or more, it would fall under the cooking equipment, and you could use a table found in cooking equipment for that. But let's not worry about that here in this discussion. Move on to another one. This is the nameplate from another one of my favorite appliances, Mr. Coffee from Sunbeam. This is a 900 watt unit. If you divide that by 120 volts, you get only 7.5 amps. If this was fastened in place, it could still go on a combination branch circuit with other appliances. It could even be a 15 amp circuit, because in the case of fastened in place equipment, there's a 50% rule instead of the 80% rule if it wasn't fastened down. Okay. And for 50% of 15 is 7.5, so it just barely make it. So Mr. Coffee, with his sunbeam-like presence, could sit and smile perkily on a 15 amp branch circuit, even if he was bolted down to the counter. However, if that receptacle was located in the kitchen, that brings up some other problems. So it would have to be hidden. It would have to be an individual branch circuit if it was in the kitchen. So even if it was bolted in place, I don't know. These rules just get so confusing after a while. But let's move on. Here's a hair dryer. It doesn't get used much as far as I'm concerned. Let's see if I can flip this around to read the nameplate. Okay, the pertinent info is 1625 watts rated at 125 volts. Notice that it's 125 volts, not the usual 120. That's okay. That's just the rating on the hairdryer. So we divide 1625 by 125. We get 13 watts. That's pretty high. Add that to the typical bathroom curling iron, and you'll know why teenagers are always tripping the circuit breaker. And it's also why bathrooms require 20 amp circuits in the first place, because they get used a lot. We don't call the bathroom 20 amp circuits an individual branch circuit though, because there could be more than one in the bathroom, and there only has to be um, one 20 amp circuit. Also, usually there are duplexes. It's handier to have more than one receptacle on your um, on your wall. So that means one individual place to plug into. So normally we have at least a duplex in there. Anyway, if it's got more than one receptacle, it doesn't meet the requirements of being an individual branch circuit. Should this hairdryer have its own dedicated circuit? No, it doesn't need one. If you have a higher powered one though, you might trip the breaker occasionally. And you'll probably burn your scalp as well. But you might consider bringing in another circuit. But because if it's in a bathroom, it'll have to be a 20 amp circuit. Anything in the bathroom has to be 20 amp circuits. You don't have the exceptions that you have in the kitchen. This is a nameplate from a portable dehumidifier. It takes half of a single phase, 115 volts. It uses 7.5 amps. It would just barely fit on a 15 amp general purpose branch circuit. So no dedicated circuit is needed for this dehumidifier. Next up, it's common to have some shop equipment in the garage. So I'm putting this one in here. This is a Craftsman radial arm saw that I bought at a garage sale one time. Let's see if we can zoom in on the nameplate. This saw's motor can be run on 120 or 240 volts. And right now it's set up for 120, but the RPMs will always be 3,450 rotations per minute if you run it at 60 hertz. So the only thing that changes is the current, which makes quite a big difference. Not in the power consumed, but because the wattage is going to remain the same no matter what voltage you put it at. But you can see if we are doubling or halving the current, it could affect the minimum wire size that we need for this appliance. And also, with the motor operated appliances, you have some different rules that come into play. So if the motor is more than a certain horsepower, then you're going to have some special rules for it. This one may need its own branch circuit. Hydro massage tubs are permanently installed bathing tubs with pumps and piping systems for recirculating water, usually with other optional equipment as well. They differ from spas and hot tubs in that they are designed to drain their contents after every use. This difference also puts them into a different category in the NEC's view. While spas and hot tubs only require general purpose circuits, hydro massage tubs must be placed on dedicated circuits according to the NEC. Now, we need to point something out. There's sometimes a discrepancy between what the manufacturer's artists depict in their instructions when they ask for a dedicated circuit and what the NEC requires. Some of the PDFs that I looked at showed single receptacles, which would be correct, but most of them depict duplex receptacles. If you can plug something else in at the same time, it technically is not an individual branch circuit. But you could put a single receptacle near the equipment and protect it from a GFCI breaker, or even with a blank face GFCI nearby to serve double duty as both the GF protection and an emergency disconnect. A blank face GFCI is a GFCI receptacle, except that it doesn't have the receptacle ports. It's just blank face, but it's got the reset and test buttons. Next up, here's the typical nameplate / manufacturer's installation instructions information for a hydro massage tub. This is just for the air bath blower, and they want it to have its own dedicated circuit with GFCI protection. There may be other equipment as well in this hydro massage assembly that will need its own attention. Remember, following the code first and foremost will always require following manufacturer's installation paperwork. In summary, the NEC calls them individual branch circuits. You might hear dedicated circuit or individual circuit. The terms mean the same thing usually, but it doesn't hurt to double check terminology. Dedicated circuits supply one and only one utilization equipment. That's an appliance or something else that uses electricity to do a particular job. If you add something else to a dedicated circuit, it loses its privileges. It's no longer an individual branch circuit. Receptacles. On a dedicated circuit, you can only have one receptacle. That means not a duplex, only a single receptacle, one single place where you can plug an appliance in. When you're hardwiring, you can hardwire an individual branch circuit or to one specific piece of equipment. You can also have a receptacle, but you can't have both. It's one or the other. There are only a handful of items in the NEC that specifically call for individual branch circuits. And we can use the rules laid out in the NEC to discover many other appliances that should have their own individual branch circuits dedicated to them. If you've got the breaker space and something is giving you problems, you're always welcome to put it on a dedicated circuit. The code doesn't say you can't do that. It just comes down to a matter of, do you have the space? And it's going to cost a little extra for the wiring and the breaker to get that over there. The time, or possibly you're paying an electrician to put that receptacle and that wiring in. So it can get expensive. That concludes this presentation on dedicated or individual branch circuits and how to use nameplate ratings on an appliance and make calculations for whether that appliance needs a dedicated circuit. Thank you for watching. If you got anything out of this video at all, Electrician Ed is a new channel, and I appreciate hearing your comments, suggestions, and if you can spare one, push on that like button, give me a thumbs up. Let me know if there's a topic or a question that you have and that you'd be interested in seeing another video on. Thank you.